This is an honor and proud privilege to introduce Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India. Professor Sood took over on 25th of April 2022, succeeding Professor K. Vijayaraghavan. Professor Sood is also the chairperson of the Prime Minister's Science, Technology and Innovation Advisory Council. He is a distinguished Year of Science professor at the Indian Institute of Science, Bangalore. He was earlier member of the Prime Minister's Science, Technology and Innovation Council from 18 to 22 and previously 2009 to 2014, and also member of the Science Advisory Council to the Prime Minister of India. Professor Sood has a doctorate in physics from Indian Institute of Science, Bangalore. His research interests include the physics of nanosystems and soft matter. He has published more than 450 papers in international journals and holds several patents. His work has been recognized by many awards, including Padma Shri, the fourth highest civilian award in India. He was president of the Indian National Science Academy, president of the Indian Academy of Sciences, and Secretary General of the World Academy of Sciences, Trieste, Italy. He was elected to the Fellowship of the Royal Society in 2015. He has also received earlier the Shanti Swarup Bhatnagar Prize, the G.D. Birla Award for Scientific Research, the TWAS Prize in Physics, the Millennium Gold Medal of the Indian Science Congress Association, the Sir C.V. Raman Award of the UGC, the Homi Bhabha Medal of the Indian National Science Academy, and the G.M. Modi Award for Science Technology, among others. Professor Sood served as the chairperson of the Governing Council of Raman Research Institute, member of the Vision Group of Nanotechnology, Government of Karnataka, chairperson of the Board of Governors, IISER Bhopal, and chairperson Board of Governors, IISER Mohali, and also he is the chairperson of the DST Committee of Vajra. So I invite Professor Ajay Kumar Sood, PSA to the Government of India, to give his distinguished lecture.
Thank you very much, Professor Ganguly. Also, a big thanks to the director, Professor Banerjee, and his team for having me for this keynote address. Indeed, I feel very privileged to be on this occasion, on this rather historic occasion, when IIT Delhi is celebrating the culmination of Diamond Jubilee celebration today. So while giving this topic, disruptive scientific revolutions at work, it's rather a very broad topic. I put it because I wanted to think aloud what we should be doing or what we are doing in S&T ecosystem and where we will be in 2013 and obviously then in 2047. So this is a collection of thoughts biased by our engagement at the Principal Scientific Advisor's Office. Some of them are being pursued there, and I am glad to see that you will see some resonance with what our Honorable President said and what we saw in Professor Banerjee's presentation on IIT roadmap and what it plans to do in coming years and what it is doing now. So I'm glad to see that this talk is not in isolation, but it is really embedded in what is happening in our science and technology ecosystem. So we all know there are 4 pillars of growth and sustainable development, which I will put as first education, science, technology and innovations. And on the right hand side, you have the 17 SDG goals, and we are all committed to adhere to these goals and achieve those goals as we go along. Now, this is a very famous diagram which talks about the balance between basic science and usefulness. So, on the x-axis, we have plotted consideration of use, how useful it is to the society, and the y-axis is the quest for fundamental understanding. So you can see that there are three quadrants which are named like the Bohr quadrant, the Pasteur quadrant, and the Edison quadrant. And ideally, what you would like to have, fundamental understanding high and the usefulness high, namely the top right quadrant, which is the Pasteur quadrant, use inspired basic research, is what would be an ideal situation, and it is of course being followed in many cases. We have the other quadrant, pure basic research and pure applied research. What I want to add to this figure, this famous diagram, is the time axis on the third axis, which is not here. So in my view, and I am sure many of you will agree, that there is no pure basic research quadrant which is not connected to the usefulness as a function of time. We all know how the crypto technology has evolved, which could not have been possible without algebraic geometry and other branches of maths. And GPS technology again embedded very heavily in basic science almost 70 years back. So this is a question of time when the basic science output, basic science feedback gets into the applied side. So there is a very dynamic process. So in this diagram, the time axis is important, and we should all realize that these are not easy to separate, calling application science or the basic science. Now we have to realize that if we need to make progress in a leapfrog manner, we have to have disruptive ideas rather than incremental growth. And this cannot happen without fundamental science. So fundamental science has to dovetail into innovative ideas, including business model, and see what are the enabling technologies which will make it possible. So here for today's presentation, today's thought process, I have put 4 verticals. I'll mention a few examples of that. One in the healthcare sector, digital technologies, clean energy, and quantum technologies. These technologies are emerging. Some of them are at a pretty good stage, but lot more needs to be done. So I thought I'll share our thoughts with you and see how we can think together in these 4 verticals. Now quantum revolution, and you all know that the first revolution which really started in 1913 when Bohr gave a model and explained spectral lines of hydrogen atom in quantum mechanical terms. 1923 de Broglie proposed particle wave duality, and of course in 1925 the famous Schrodinger equation came along with the matrix mechanics of Heisenberg, Born and Jordan. This was the first revolution in quantum mechanics or quantum physics. It really showed that there are this enabled, quantum mechanics enabled things like transistors and lasers, and it was immediately realized that the special properties are because of quantum mechanics. But what is very different between first and second revolution is that the quantum systems are not being controlled. Here we are not talking of controlling the quantum systems at individual levels. And this is precisely what is happening in second revolution, which is happening now. So we are aiming, and we have succeeded to a great extent, controlling individual quantum systems, entangling individual qubits to transform information. And this is the second revolution I am talking about. So let me just give you 101 for 30 seconds on QM. All of you may not be in this domain. Just a quick thing, that in classical domain we talk of bits 0 and 1. So what is different here is we are not talking of 0 and 1 separately, but we are talking of superposition of these states, and the system can be in 0 and 1 simultaneously with the in the superposition principle. And what is also possible is the entanglement of these qubits. So the qubits is not 0 and 1, but the superposition state, which I have written A 0 plus B 1 state. And what is important here is the entanglement of these states. And so the quantum bits or the qubits, you have to realize that they are fragile, their superposition can break, and their entanglement can also be destroyed. So the measuring value of one qubit immediately determines the value of the second entangled qubit, which is a great thing when you are talking of quantum communication. So we need to create enough entangled qubits, this is the game, which are long lived to do useful calculations. Now there are many candidates now which are being pursued all over the world. For example, superconducting circuits, Josephson junctions, and trapped ions, and so on. So we will still do not know which one will win the race, but all these 5 or 6 possibilities are at a very advanced stage of being pursued all around the world, and we are at a very beginning stage to see what could be the advantages one over another. And this is what the quantum frontier is. So the first thing which you must have seen is this quantum supremacy. So this quantum supremacy refers to the problems which cannot be or impossible to do using classical computation, but you need quantum computers to really solve this problem. And that is the true meaning of quantum supremacy. This word was coined by John Preskill about 10 years back, and you must have seen a paper about 2 years back or 3 years back in Nature where Google claims quantum supremacy by making this quantum computer with 56 qubits which are entangled and performing certain job. So already there is a great hope and a success already demonstrated. So the point here is that if we have this system, there is the desire and the aim to make quantum simulator to simulate classical phenomena that classical computers cannot do, and that is the real quantum supremacy. So Charles Monroe has articulated very well that the biggest application of quantum simulators will be in optimization problems. For example, the traveling salesman and similar things, which are exponential in complexity. So the idea is, if we have such a simulator, can we really have quantum model of the photosynthetic molecule which I have shown on the left? You might have seen that this is a highly controversial topic where it has been debated even now whether the quantum coherence has anything to do with the high efficiency of photosynthetic process. The final verdict is still being debated, but probably not in coherent sense, but it's a great problem for a quantum simulator to see all the pathways which can be understood using quantum simulator for understanding this high efficiency. If we succeed in that, then of course we have a whole lot of possibilities open to apply to drug design, pharmaceutical, cellular functions, and so on. So this is what is a game changer will be in coming years. And question is, can India play some role in this frontier? So India has a mission on quantum technologies. This was discussed about 2.5 years back, 2 years back in PM Steik meeting. And in fact, I made a presentation at that time to our Honorable Prime Minister that India must launch quantum mission. And this is all done, and it's about to be launched with DST as the nodal agency and many other ministries involved, which will have 4 verticals: quantum computing, quantum communication, quantum sensing and metrology, and quantum materials and devices. And who will benefit is very obvious. All these sectors, right from communication, health, financial sector, energy, space, defense, transportation, and gigafactories, will be the obvious beneficiary of this revolution. In quantum communication, I'll just take 1 or 2 minutes to again highlight what are the challenges for us, challenges for the young people, that we all know that classical messages are sent by encrypting, and then along with the message you sent a digital key to decode. Obviously, when you have a hacking, the key is hacked and you lose the information or you get it corrupted. The simplest idea is that when you do this, do the message, of course the classical, the encrypted message you send in a normal way, but the key is quantum. So the encrypted data as classical bits over networks, while keys to decrypt are encoded and transmitted in a quantum state using qubits. And that is why you see many protocols of QKD, quantum key distribution. And now when you want to use entangled photons over fibers, obviously you will have restriction for few 110th kilometer because of the losses, and then you have to put repeaters. That is what is done in classical communication as well. Here the problem will be, how do you do that? So the process which has been already implemented in this already over 2000 kilometer, by putting repeaters every 30 kilometer, that at every stage you decrypt and then you encrypt again after amplifying, and you keep on doing that. But this is not really sustainable or the efficient one, and it can be hacked at the point where this is happening. So the need of the hour is quantum repeaters, where quantum keys are decrypted into bits, and then this is what is happening. But to avoid that, you make quantum repeaters. And of course, quantum teleportation is the obvious step, using distributed entangled photons. And obviously, all of us dream that in few years we will have quantum internet, where challenge is to find reliable ways of churning out lots of linked photons on demand and maintaining their entanglement over long distances. This is the dream, and I am sure India should play a role and will play a role with the quantum mission launched. So this is a small baby step which has been done in recent time. There was a news. There are other things with IIT Delhi was shown. So this is quantum key distribution demonstrated over a short distance, but longer distance have also been done. And this is just to tell that we are already in this thing, but we need to do at a faster pace and in a more innovative manner. This is again to say that when we are talking of quantum, the new materials have to come. We have to see what are the possibilities of new materials like 2D materials and so on, and how the bulk semiconductors like silicon and gallium arsenide or gallium nitride can be beautifully supplemented using new materials based technologies. Second is the digital revolution. I have few minutes, about 7-8 minutes left, so I'll just point out few other 3 more verticals. Digital revolution is already happening. It's not something which we have to wait. Already you have artificial intelligence, machine learning in a big way, augmented reality, virtual reality, mixed reality coming. Internet of Things is already there, and blockchain technology. All these disruptions are in our reach. So what I want to just flag for a minute is the possibility of having virtual reality in a bigger way. So can we have this virtual reality as a disruptive technology for the next decade, where we have to go beyond gaming. Gaming industry is already very much into it, and enormous amount of talent exists in the gaming industry. So here it is predicted that augmented and virtual reality market grow to about 30 billion US dollar by 2030, and see whether India can play a dominant role. And COVID-19 has put the spotlight on this hands-free interactive technology, and it is unlikely that this focus will move for some time. And this has many challenges. We need to work on the hardware and the software. 5G technology obviously is a must, but even on the hardware, like the VR headsets and so on, are really looking at us, these challenges, where Indian ecosystem, Indian startups can play a big role. So this is what you must have heard in the last few years, because Facebook named itself as Meta. So the metaverse, which is the buzzword which was coined by designer of this game Second Life. So here we are talking because the internet is mostly two-dimensional, 2D now, but the idea is that the internet will become three-dimensional, and this is what is called metaverse. So again, you must have seen Facebook is into a big way. It is only telling that there is a huge potential. It is not to advertise Facebook for me, but only to convey that many players are into it, and it is expected that this will be a huge market and huge innovation field as we go along. So these are some of the applications for science and society in metaverse. It's not only for games. You will have a huge potential in interactive science labs. In the remote corners, we could have this possibility where students can be educated, technology can be imparted through this metaverse, making education and science more accessible. Virtual commerce, of course, will flourish, and also we can have empowering of the workforce by this training using this metaverse, and strategic capacity building, for example, even astronaut training and so on. So this is not something like a science fiction, but it's a reality which is taking shape. So we are at a stage when we are ready to get into this in a much bigger way, and that's the reason I put it as the second vertical. The third vertical, very briefly, I'll tell you the health sector, which is at a cusp of a revolution. And nothing could be better said than the COVID-19 response we had as a country in the last 3 years. So we know that we had this mobile infection testing system, which really incorporates the BSL level 2 laboratory, which has all the diagnostics and all those things in this mobile van, where our office played some role through Strategic Alliance Division, partnering with the corporates to make it possible. Another one, which is something which is already happening in India, but it has to happen at a much bigger pace, is that we must go digital in this, of course, but also use the tools like machine learning, like deep thing, which was DeepMind, which was shown about 3 years back by Google. Many players are in this. So using the CAT scan, the data of the patient, you do this supervised or the unsupervised learning, and really it should become a norm. So when you do a CAT scan, the first take should be by these algorithms which tell you what could be the possible diagnostic. And of course, it will not replace completely the experts, but it will make their life much more easier and efficient. Already happening in many places in the world. In our country itself, there are few startups which are doing this, and it is a huge market for various diseases like in cardiovascular, liver and lung and so on. So this is how the healthcare will look like in 2030. You already have, for example, from the eHealth Kerala website, you can see that electronic health records for documenting patients' medical history are being done, and then you can have e-consultation. And on the right hand side, we have the health facilities equipped for basic screening, identifying the risk, and telemedicine through augmented reality and virtual reality. So I hope this can go in a much bigger way, not only cities, but also primary health care and so on. And this is what we should aim for in 2030. Now, this is a slide just to emphasize the medical devices is a huge potential which has just barely been tapped in India. If you go around the hospitals, you will see that 90% of the devices are imported or machines are imported, whether it is MRI, whether it is the ultrasound, whether it is the CAT scan, and so on. Only in last few years, we have started making some progress. So this is a field which is hugely technology driven along with medical fraternity, and it will make a big difference. For example, I have shown first ever electrocardiograph on the left top, which now we have the early ECG machine, and now in recent years we have mobile based ECG monitor which has been developed in our country. We had again some connection with this through our Agni mission of PSA office, which is why I have shown it. We also have enormous progress in MRI being made in India, and I hope it will come to the market very soon. The last one is the One Health mission, where we are not talking of the human health in isolation. We are talking of human, animal health and the wildlife together. COVID has taught us very, very clearly that you cannot take human health in isolation. There is a enormous crossover between these three domains and of course the environment, and you have to do this together. You should have an integral surveillance system, disease outbreak response, and preventives for emerging diseases. So our office, Principal Scientific Advisor's Office, we have made a discussion with all the stakeholders to launch One Health mission. And already things are happening in few ministries. We are trying to see how to make it more holistic and more wholesome for making a difference, to look at the key emerging disease mapping and many, many things in surveillance and so on, which is, I hope, will be a norm rather than an exception in coming years. So this is what I have shown that the disease preparedness is no different than actually the natural disaster, which I have shown on the left hand side, and below that you have this oxygen cylinders as they are refilled in the COVID time. So you need surveillance, you need investigation, you need outbreak response, and you need mobilization exactly like natural these disasters. So it has to be considered in a disaster mode. So the last one is on the climate change, and what stares at us, our focus, all of us, without any exception, have to be on climate resilient development. A whole world is talking, India has committed to this, and the reason is very obvious. I will not dwell on it, that the CO2 emission, if you see, and the global warming after 1950, which is what the point I have written, has been a huge explosion of this, madness. So this madness has to be stopped, and on this right hand plot, I have plotted from the well-known report the global warming temperature, the temperature rise, and the cumulative carbon dioxide, which again you can see is very alarming if it really, if you have to prevent this global warming. So already it is a challenge. So the climate change is not an exception. The Europe heat wave, which you are all seeing, the water shortage, all those things are the reality. In India, we have enormous number of disasters, the cloud burst and so on. We have to really see how do we tackle this climate change possibilities and no longer in a subdued manner. There are many verticals on this, which is what Prime Minister's goals of Panchamrit says, achieve net zero by 2070. So there are many interventions which are needed. And one of the intervention is a possibility, is to go green hydrogen route, which was also mentioned in Dr. Rangan Banerjee's talk, as well as in Honorable President's talk on these new technologies. So green hydrogen is the way, one of the ways, again just to say what this hydrogen means. H2O, very famous. Here we have various shades of hydrogen, but what we need to emphasize is to look at the green hydrogen, probably through the electrolysis route, using renewable electricity, not the conventional way of making electricity. Then it is really not green, because you will consume, you will again have the carbon addition. So this is what one recent examples, again you would have seen from my alma mater, Indian Institute of Science, where the biomass produced hydrogen, converted into syngen by mixing it with steam, and that is shown to be much better source of hydrogen than the conventional way, conventional way of biomass. So again, lot of expectation. This is a roadmap produced by MNRE, which is very clear that we need to go on this. Good news is that the green hydrogen mission is about to be launched with many ministries involved, many labs involved, and again with a lot of encouragement coming from the government on this hydrogen mission. I will not close my talk to say that we have to go innovations on the way, right from development of electrolyzers in a very efficient manner, to the from generation to the storage, and then to the usage, for example in mobility sector using of course fuel cells, but also in fertilizer and steel industries. So I think I'll just mention, which is not what we are doing, fusion cannot be left behind. Fusion is on the way. Of course it is taking time. The ITER program you would have seen, this has been delayed little bit, but it is on, and India is a partner in that. This is the site in France, and various timelines, and India is a player in that, where it has the responsibility to make the cryogenic system, the cryostat, for this ITER program. So India is very much there, which joined somewhere, which I have written here, 7th country to join, and we hope that in coming years we will see more progress in fusion. So let me close this talk by bringing the slide back where I started, that we have all this basic science, technology, innovation all put together to make the breakthrough in a disruptive manner and not in an incremental manner. And in my this talk, I just touched upon, without giving elaborate discussion or the details, and this is not exhaustive. It does not mean that there are not things outside. There are huge number of things which I did not touch upon. I touched upon on quantum revolution, I touched upon digital technologies, then healthcare and clean energy. So with this, I thank you once again, and I wish you at IIT and all the people who are connected with IIT and otherwise, another 75 years of excellence in your mission of this high quality education and promoting science, technology and innovation in a holistic manner. All the very best to you, and look forward to many more things from IIT Delhi. Thank you so much.